Hey fellas, it's Structs here. Today I'm going to be doing a video on basic C++ concepts you're going to want to know. Well, I wouldn't say basic, it'll get a bit in depth, but you know, the concepts you're going to want to know to make your way around C++ and C in some areas, but not all of it. Alright, if you are a noob, you probably want to get off of this video since you barely know your way around C++ in the first place. You don't know how to use it at all. But if you know a bit of C++ or even a bit of another language, you should be able to make your way around it. Have basic programming knowledge. Alright? So I'm going to be using Qt Creator, which is a pretty solid IDE, but of course you could use whatever IDE you want. It's a standard language. Just as long as it compiles and you can see output, it'll work. Alright, so let's hop right into it. So the first concept we'll be exploring is pointers. Now, a lot of people hear of pointers and they have no idea what they are. They're like, oh, it's this fantastical, mystical thing. I don't know how they work. Well, pointers are simple as shit. What a pointer is a variable that points to a location in memory. That's it. That's a pointer. So, first let's just take a look at a regular variable. We'll say int a equals 0. Or let's set it to 4, spicy. Alright, so this is a regular variable that holds an integer value. We can do whatever we want with this. Let's just print it. And we'd get 4. Alright, so bare basic variable. Now, what a pointer is, we're going to do int star. This star is what says it's a pointer. And the int here, this could be anything. This could be void. This could be bool. It could be any data type. A pointer could be any data type. It could be null, whatever. That doesn't matter. But since we're going to be pointing to an integer, we put integer here. Alright, so p underscore a for pointer a is equal to and a. What and does here is it gives us the address in memory to a. So it's giving the physical address in your RAM to a. So if we were to print p underscore a now, we'd get this arbitrary memory address decided by the system. Alright? So that's a pointer. That's it. That's the bare basic concept of a pointer. We're pointing to a location in memory. Alright? Now, so where it gets a bit more complex is the application of a pointer. Why in the fuck would I want to use a pointer? You're probably thinking, like, doesn't make any sense. Why do I want the direct memory value? Well, let's say we have two functions. Int change var, int var, int val. So we have this function here. We'll have another function, int change var p, int a pointer to var, int val. Alright, so we have these two functions. Let's look at the first. So, obviously, probably implied by this this function, we're going to want to set var to val and return it. So we could just do var equals val, return var. All fine and dandy. So let's just use that function real quick. Let's do a equals change var a 7. So if we were to print out a, we'd get 7. Pretty simple. Now, so you're probably wondering, alright, what the hell? What's wrong with this? Now, this is generally fine, but you're not going to always want to do change a in this way. Because you see here how we do a equals the output of change var. So we're saying whatever this function gives us, we're reassigning a to it. Sometimes you don't want to do that reassignment. Sometimes you don't want to do a equals the output. Sometimes we want to change a directly. We want to look at a, change the value right there. Because what we're doing here is we're making copies. This is a copy of a. This is not a directly. This is a copy of a. And so you could probably logically see this is where a pointer goes in. Because if a pointer points to a location in memory, that means we could change what's in that memory directly. Alright? So let's comment out a here. Once you see it in effect, it'll be less confusing. Alright. So on change var p, let me just write this out real quick. We'll do star var equals val. Now, so this is obviously, again, a pointer to an integer, the memory address of an integer. And what the star in front of var here does, don't confuse this with the pointer. This is the dereference operator. Now, to put that in human terms, this gives us the value in the memory address. So if this points to a memory address, putting star in front of var, putting star in front of var will give us the direct value. So instead of getting whatever this shit was, we'll get 4. Alright? Pretty simple. We'll get... So if we were to, like, just print it out from there, it'd be 4, whatever. Alright, so now we can see this function in effect. We'll do change var p, p underscore a, 8. You see what happens here? We get 8. Except we did not assign a equal to it, because we changed it directly. We looked at where a lives. Oh, you live here? Well, I'm going to go into your space and change you. We're not making a copy and reassigning it here. We're changing it directly. This is called passing by reference and value or something. I don't care about the terminology. I just know how to use it. Alright, yeah, so it's that simple. And so you're probably wondering, why would I want to do this? Like I said before, sometimes you don't want to reassign it. Sometimes you want to change your variable directly, and that is a perfect application of a pointer. Alright, and there's this really good analogy I like on pointers and shit. So let's say you're trying to buy some dragon dildos. You go to Amazon or whatever, you buy your dragon dildo. And so how are you going to get that dildo? How are you going to get that dragon dildo? Are you going to clone your house, bring it to the warehouse, and put it in your house from there? I don't know, whatever weird use case you have for that, but sure, maybe. Or are you going to give the warehouse the location of your house and mail it to you? You see where that's going? We want to give it directly. We're not going to take a copy of our house and give it to the warehouse, and then the warehouse is going to change it, and then it's going to give it back to us. Let's just give it our house and keep that a bit more simple. Alright, so you could think of var here is the location of our house. We could look at val as the dildo we want to put into it. Here we could look, this is a copy of our house, and this is the dildo we want to put into it, and put in here, this is taking our house to the warehouse and giving it back. So you see, that's the application of a pointer. It's pretty simple. You could get into more complex parts with pointers, but we don't need to concern ourselves with that yet. Alright, so that's a pointer. The next concept we're going to be looking at is what makes C++, besides for the atrocious standard library, classes. These are the templates for an object. Alright, so we can make objects and they contain methods and properties, and we could play with those. So we'll have class animal. Pretty basic analogy they like to use for classes. Now, so to denote something as public or private in C++ classes, which public means anything that has a reference to the object can use it. Private means only the object itself can use it. So let's just show an example real quick. To denote public and private, you put public and then colon, and private and colon, and whatever is under this is public or private. You also have protected, but I'm not going to go into that right now. So, class animal. Let's have std. Most members are usually going to be private, because you don't want anything finagling with your class, so we'll have name. Right here, this is going to be a constructor. This is a constructor, which basically is first called when we run our object, and we can give it whatever parameter. So we'll have stt string name, and this name equals name. And so what this part is doing here is it says, all right, I'm gonna look at the object directly and find the property name, which is this. The reason we do that here is because we give it a parameter with the same name. of the property. So if we just did name equals name, it wouldn't know what it's assigning. Or it would just be referring to this. So that's why we use this name here. You don't always have to use this in reference to properties the class holds. Anyway, so let's give this a function. Void say name. And so what this is simply going to do is print the name. So you can see we didn't have to use this here. We just use that to, since there's two variables the same name. So std count name, whatever. We can construct this animal by doing animal, anim, and then we pass in these. This is basically calling the constructor here. Boring. This is a pretty boring animal, so we'll call him boring. And so then we could call our method say name, and we'd get boring. Easy. We're assigning it here. It puts it here. When we call say name, we access it. Alright, so that's basically a class. That's a bare basics. Now, let's say you want to overload or overwrite or derive a class off of another. We'll do class cat. This is a specific animal. This is the kind of idea of an animal, but you're probably not going to want to instantiate this animal by itself. We want to add functionality onto the animal. So we'll do class cat, colon, public animal. Basically, this is saying, let me get all the public methods and whatever I believe. Let's add another method to our bare animal. It's going to be a virtual method. Sound, virtual void sound. And this will just do std count. I have no sound. Oh. Right, there you go. So we could just do anim.sound, whatever. And then we get I have no sound. Alright, so this class cat, which is derived off of animal, we can override this. It's virtual. So it's basically saying, hey, can you please override me? That'd be pretty cool. And so we're going to implement that. Because our cat has a sound. It's going to have a sound. Meow. This one is boring. He has no sound because he's a basic animal. He's what an animal might look like. Alright, so first, it's going to have its own constructor. And we're going to give it string name. And since we're going to want to use the same functionality as this constructor, we don't want to have to rewrite it. That's kind of redundant. What we can do is we could call animal name. And this will call the base constructor. Alright, you could ignore these warnings. That gets a bit more complex. But so this is just passing in this into this constructor. Since it's derived off of animal, so we can pass it in and it'll just work. Alright, so say name is going to be the same. This gets copied into this. Alright, because there's nothing denoting it. Now virtual, we can override it. So this is where we're going to add in our different functionality. Virtual void sound. And he's a cat, so he's going to say meow. Pretty simple. Now, void say name, like I said before, is going to stay the same because every animal should be able to say their name just fine. But this one is going to be different. Alright, so we could see this in effect. Cat, whiskers. Oh, an error. Calling private constructor of class cat. Ah, I'm dumb. Forgot to add public here. I'm really dumb. Alright. So we have cat whiskers, and we could do cat.sayname and cat.sound. And so we'll see when we run this. Wow, it's different. We overrided this class to say meow instead of I have no sound. But what we could do, get rid of that, And you'll see it inherits I have no sound, because we did not override this virtual function. So that's pretty neat. And that's the basic idea of a class, alright? It's just these little objects. We could add functionality, parameters. All is fine and dandy. Alright. Next, we will be looking at structs. Structs are basically classes without private and public shit, but they're still useful to use. Struct animal, I believe. And they're stupidly similar. We'll do std string name. And we could just make a struct with animal. They don't have constructors either. We could do animal dot name equals whatever. There you go. And it's kind of like a class. That's basically a struct. It holds data. I believe it could have methods, but it just doesn't have public or private. And I believe the polymorphism on it is different. That doesn't matter. Alright, let's look at another concept. Headers and source files. So to start out, I'm going to be making a class. This is a Qt creator thing. It generates your class for you. So I'll do test. No. This is just a little CMake thing. Hold up. Alright, so here we have test.cpp and test.h. We could ignore these bits for now. Not really important to this tutorial. So what the header file does is it defines our class or whatever you want. You could also just have function definitions here. They're often used for classes. So we could have whatever we want. Let's just have a private int a, and then we could have some function void func here. Now you'll see here we aren't giving these functions we aren't giving any of this a definition. This is because we put it in the CPP. So this basically lets us, this is our outline for the object. It doesn't have any of the functionality yet. It can, but you know, defeats the purpose of a header. And then in this file, this is where we add our functionality. So we could do like void. The test is to say, hey, we're going to be talking to this class. We can do func here. And then we give it functionality here. We could do int b a equals 1, whatever. And so if we want to use this object, we include it like this. We include the header file. And then this file includes test, and so we get all the functionality together. It's just like a splitting of code. And then we could do test, or what I call the class? Yeah, it should be test a. And then we could do a func here and it'd run. That is a header, whatever. So actually, that's going to be pretty much it for this video. These are just the concepts I wanted to explore, and I hope you enjoyed. I am dumb.